the discussion. Let's continue the discussion, and I'm sharing the screen again. So up to this, anyone has any doubt? Tell me. Do you understand how I have calculated the information gain for this given system, or for this given data set, for the entire data set of the play tennis? Okay, for the entire attribute of the play tennis. Is it clear to everyone how I have calculated 0.94, the entropy or the information gain for the entire system? Do you understand it?
Yes, sir.
Okay.
Yes, yes.
Okay, fine. Now our job is to calculate the next entropy of the first attribute, that is outlook. Entropy or information gain of the first attribute, that is outlook, with respect to three different values under which the outlook has been saved. That means sunny, overcast, and rain. So these are the three values. With respect to these three values, we have to calculate the entropy or information gain of the outlook, right? How we can calculate? Very simple. The same formula will be applicable. Now first we are calculating the entropy of the outlook variable with respect to sunny. Sunny is the first kind of value of that entropy of that outlook attribute. So information gain or entropy of the outlook based on this sunny. So how we can calculate it? The same formula, how many sunny and how many p plus n. So how many sunny are there for which it is positive? So here, how many sunny are there for which the value is positive? This is the one sunny for which it is positive, sunny and yes, right? Play tennis respect both sunny and yes. And there is one more sunny which is positive, sunny and yes. So two sunny are there which is positive. This is one and this is second. And rest of the sunnies are negative. No. Okay. So two sunnies are positive. So our p should be, p value will be 2. And how many negative sunnies are there? Total n value for negative sunny, p plus n actually. So n should be 3. N should be 3. Why? Because this is no, these two are no, and there is 1, 2, 3, 4, 5, and there is one more no. So 3 no's are there with respect to sunny. So total number of negative classes with respect to sunny is 3, and total number of positive classes with respect to sunny is 2. Okay, so p is equal to 2 and n is equal to 3. So simply we put the same thing in this formula. P is equal to 2 and n is equal to 3. That means 3 plus 2, 5. So it will look like this. The formula will look like this, and the information gain with respect to the sunny is 0.971. Okay, so with respect to sunny it is 0.971. In the same way with respect to overcast, so there are total 4 overcast positive and 0 overcast negative. Let it check. So overcast, how many positive classes are there? Overcast, yes, first positive. Overcast, yes, second positive. Overcast, yes, third positive, and overcast, yes. The chatte overcast are, and all are positive with respect to the system class or the target class, right? In case of outlook attribute. So, and there is 0 negative classes in terms of overcast. So that's why positive classes are 4 and the negative classes are 0. So this, in this respect, we'll again apply this formula for the overcast, and we will get the information gain corresponding to the overcast value of outlook variable is 0. In the same way, we'll calculate the rain, and we'll get the information gain for the rain value with respect to the outlook attribute is 0.970. So these are the three values that we will receive. Okay, total 3 values that we will receive. Now we are again going to calculate the entropy of the entire attribute outlook. How we can calculate the entropy of the entire attribute? By the help of this formula, summation I equal to 1 to v pi plus ni divided by p plus n into information gain of the entire system. Which one is this one? Information gain of the entire system, this one. Okay, information gain of the entire system 0.94 is this one, and positive and negative classes that we are going to calculate. So here with respect to outlook, so there are total 5 positive classes and total 2 positive classes and 3 negative classes. So pi means with ith respective, when I equal to 1 to v, 1 to v means total number of, these are the total number of variations. So here I 1 to v should be 3. Okay, so 1, 2, 3, there are total 3 respective values of the outlook attribute. There are 3 respective values of the outlook attribute, 1, 2, 3. So that's why this one for the sunny, this one for the overcast, and this one for the rain. Okay, 3 components or 3 values with respect to the outlook attribute, right? So the total number of positive and negative in with respect to sun is 2 plus 3, and total number of classes is 14. The total number of tuples of classes or total number of tuples is 14. Okay, so this p plus n is means total number of positive and negative VSS. Okay, that is 14. So 5 by 14 into the information gain of this corresponding sunny value, that is 0.970. Again 4 by 14, 4 by 14 with respect to overcast, 4 by 14 into the information gain that we have received in with respect to overcast value of the outlook attribute, that is 0. And then 5 by 14 with respect to rain attribute, and that is also 0.970. And if we summed up or added all these values, then the entropy of the outlook will be 0.692. So in this way, we'll calculate the entropy of the outlook. Now we are going to calculate the final gain of the outlook. That is the major aim or major objective, to calculate the gain of the outlook variable. This is a gain. So how we can calculate the gain of an outlook variable? Very simple. The information gain of the entire system, that is this one. The information gain of the entire system, that is 0.94, that is this one, minus the information gain or entropy of the outlook attribute, that is 0.692. So 0.94 minus 0.692 will give you the value of 0.248. So in this way, we are able to calculate the gain of the outlook attribute. Now the same all the same strategy will be repeated for all the 3 other attributes: temperature, humidity, and wind. Okay, and we will have to calculate the gain of all these respective attributes, including outlook. We have already calculated the gain of the outlook. In the same way, we'll calculate the gain of temperature, humidity, and winds respectively. So these are the 4 gains of temperature, humidity, and winds. আমি এখানে ডিটেইলসে দেখাইনি, at your home you will have to try it out. Okay, clear? So these are the 4 gains that we have received. This is the gain for outlook, and these 3 are the gain for the other attribute. Now we will have to choose the gain which has a maximum value, the maximum gain of an attribute. So among these 4, which has the maximum gain of an attribute? This one, the outlook, 0.248, but rest of the things are the minimum. So this attribute will be the root node of the first level of the tree. So the major root node of the first level of the tree will be outlook among these 4 attributes. Okay, and then the outlook will be divided into again sunny, overcast, rain, among these 3 attributes. Okay, 3 values, and then respect to sunny, then again we will have to do it. And I'm going to discuss the rest of the things in my next lecture, because right now we don't have enough time to discuss it. Okay, the rest of the things I am going to discuss in my next lecture, that how we can calculate or how we can evaluate the attribute, the root node for the next level. So first level root node I have already calculated with the help of this gain. Aki technique we are going to apply, but that should be applied in different way. Okay, that should be applied in different. What is the different way, that I will discuss in the next class. Okay, so up to this, everyone is clear how to calculate the root node of the first level of the tree? Is it clear to everyone? Tell me. Anyone has any doubt, any question, you can ask me. Up to this, it is clear to everyone how I have calculated the gain or entropy and to select the root node of the first level of the tree? Bolo, is it clear to everyone? Hello, give me a response. Is it clear
Yes,
to
sir.
everyone?
Yes, sir. Yes, sir.
এটা কিন্তু everyone
Yes, sir.
please
Yes, sir.
everyone please revise it by today before appearing the next class. Please revise it, otherwise I will have to again repeat it. তোমার রিভাইজ না করলে আমাকে আবার
ডকুমেন্টটা শেয়ার করতে পারেন।
yes I'm sharing the document. Obviously I'm sharing the document, but till now I didn't complete the decision tree yet, because decision tree is a bigger one. It is one of the biggest classifier. So till now I didn't complete it yet, but please revise it how I have calculated the root node, because the same approach I am going to apply for the calculation of the root node of the upcoming levels of the tree. Okay, so please revise it how we have calculated the entropy, how I have calculated the gain. Please revise it. Okay. Okay.